Hi, and welcome to Meetings in Math. We're here for 6.4, comparing linear and nonlinear functions. Our essential question is, how can you determine if a function is linear or nonlinear? Today you'll need your Jaguar Jots on section 6.4, a pen or a pencil. You might find a highlighter useful, problem-solving skills, and bring your inspiration along with you. Let's get some definitions out of the way. Nonlinear functions do not have a constant rate of change, and their graph is not a line. When linear, when I say that, you think of lines. Nonlinear means not lines. So we're going to be looking at some different examples, and does the table represent a linear or nonlinear functions? Basically what we're looking at is, do we have a slope? Can I make a slope out of these equations? So the easiest way to do that is to look at the change between the numbers. So between 3 and 4, I added 1. And between 4 and 5, I also added 1. And between 5 and 6, I again added 1. So our delta x is equal to 1. So if we're thinking of slope, we know slope is equal to delta y over delta x. And so far, I'm on my way to making a slope that is over 1. So now let's look at y. If this works, I'll have a nice delta y. From 1 to 2, I added 1, and from 2 to 3, that was an increase of 1, and from 3 to 4 was also an increase of 1. So we have a nice delta y as 1 as well. And so when I take that, m would be 1. So since I have a nice slope, this is linear. So it is linear because there is a constant rate of change. And if you remember that when we just say constant rate of change, we mean slope, that is the key. So let's look at the next one. Between 2 and 5 is a 3, 5 plus 3 is 8, and 8 plus 3 is 11. So far we have a delta x of 3. So it's looking pretty promising. If m is equal to delta y over delta x, we have something of over 3. So let's go look at our delta y. 4 to 7, that was a 3. 7 to 12 is a 5. And 12 to 19 is a 7. I can't write a single number down. They're all different, which means I don't have a constant rate of change. I don't have a slope. So this is not linear. I don't have a slope. So this is non-linear. So it's non-linear because there is not a constant rate of change. I cannot write a slope. So that's how we do it with the table. Now let's look at one that's really easy. Look at this one right here. Is that a line or is that not a line? That's all I'm asking you. Is it linear or nonlinear? If you look at this, oh, my finger did not make a line. Therefore, it is nonlinear because it is not a straight line. Yes, the question is really that easy. Now let's look at this one. This one might be a little bit harder for you to see, but it is this part right here. That is linear because it is a non-vertical straight line. Now there is a reason I said non-vertical. If the line was to go straight up and down and be vertical, that is not a function. That is just one of those rare cases we have to be careful of. So it's not on here, but let's go ahead and draw a quick sketch. So I'm going to show you what I mean when I say non-vertical. So there's our XY axes. Give yourself this as the line we're going to talk about. That there is not a function because it is a vertical line. Vertical lines cannot be a function. So it's nothing to do with linear or non-linear, just a reminder that vertical lines cannot be a function. A lot of people forget that, and I just kind of want to give us that quick reminder. So we're going to classify things as linear functions and nonlinear functions. And really what we're looking for linear functions are things that fall into the y equals mx plus b category, or the y minus y sub 1 equals m times the quantity of x minus x sub 1. We're familiar with those two equations. We've used them in the past. Nonlinear is when you end up with exponents fractions when the denominators are variables. Those are kind of your keys. Those are like your two biggies for each one. What we're going to do is we're just going to go through this list and talk about which ones are linear, nonlinear, and their reason why. So usually it falls into one of those 4 reasons why. So the first one, y equals 6x minus 3. Linear or nonlinear? It doesn't have any exponents. It looks like y equals mx plus b. That is linear. The next one, y equals 6x squared minus 3. I said squared right here. That is nonlinear. Y equals 4x squared. So that little caret that you might see sometimes, that also means squared. So if I said squared again, same reason, nonlinear. So this is y equals 4x squared. And only the x is being squared here. So it's the same reason. Why don't you do the next 2? So if you thought the first one was linear, you're correct. This is y equals mx plus b. It just so happens that it's y equals 0x plus 4.7. And the next one is also y equals mx plus b. When you simplify it out, it's y equals 7x minus 14. So what did we say about fractions? Some fractions are and some fractions aren't. The fractions you have to watch out for are when the denominator is a variable. Otherwise, it's okay. So this one is linear. It's y equals mx plus b. If we want it to look more like y equals mx plus b, it's going to be this. Y equals 1/4 x plus 0. And this one is non-linear. It gives a funny looking graph when you do it. It kind of does this, kind of a curve. Like this and like that. It looks kind of funny when you graph it. That was really fast. What I would like you to do is I would like you to explain to your parent, a sibling, your stuffed animal, your pet, whoever's willing to listen to you about linear and nonlinear functions. Thank you so much for joining us. And remember, be kind to each other because we can all use some extra kindness in our lives. Bye for now.